Hi everyone and welcome back to Dev Portal, your go-to channel for mastering Java and tech concept. In today's video, we are going to explore locks and atomic variables in Java, two important features that will help us to manage concurrency and ensuring thread safety. So first, let's discuss what we are going to cover today. We will start our discussion by understanding the problem with the synchronized method and synchronized block. After that, we will see how lock can help us to overcome from this problem. And then we will introduce you to the atomic variables for lock-free synchronization, and along with this we will share some best practices while working with lock and atomic variables. So let's start our today's discussion. So first, let's try to understand what is the problem with the synchronized method and synchronized block. As I told you in my previous tutorial that the synchronized keyword in Java ensures that only one thread can access the critical section of the code and other threads will go into the block state, and it will help us to prevent from the race condition. However, there are some problems that you may face while working with the synchronized keyword. One is that once a thread enters into the synchronized block, all other threads trying to access that resource, it will go into the block state even though they only need to read the data. And there is no time guarantee as well that how much time they have to wait, as a thread can go into the indefinite amount of time for the block state. And along with this, synchronized does not guarantee us that which threads will get the lock first. And if multiple threads hold the locks and wait for each other to release the lock, in that case, what will happen? A system will go into the deadlock state as well. So first, let me show you that how we are writing the code with the synchronized keyword, and then I will show you the same output we can generate with the help of lock as well. So what I'm going to do, I will create one shared resource class, and under that shared resource class I will create one instance variable of type integer for the counter, and that counter we will try to increase with the help of threads. So first let me create one class here. So I will create class shared counter, suppose, and under this I will create one instance variable private int count. And I will create two methods. One is for incrementing the count value and one to get the count value. So first is public void, and here I will give this a name, suppose increment. And what I will do, I will just increase the value of this count here, count plus equal to 1. And after that, what I'm going to do, I will print sysout statement, and I will print the current thread name which is accessing this count value and trying to increase the value. So let me write thread dot current thread dot get name, and after that I will print count value as well, that is count. And to make this method a synchronized method, I will do one thing, that is I will add synchronized here after public. So now only one thread will be able to access this method and other threads will go into the block state. And let me do one more thing, I will create another method here to get the value. So it is get count, and it will return me the count value. So that's it, we have created our shared resource class, and now what I'm going to do, I will create two threads who are trying to increase the value of this count variable, and then we will print the final value as well. So first let me create the object of this class. So I will write shared counter, and let me give this a name, suppose resource equal to new shared counter. And after that I will create one task first, so it will be runnable. If you don't know how to create threads and how to create runnable tasks, then you can watch my previous tutorial, link I will give you in the I section. So I will write runnable task is equal to, and here I will use lambda expression to define my task. So what I'm going to do, I will write one for loop which will run 5 times, and every time it will call the increment method. So I will write for int I is equal to 0, I should be less than 5, and I plus plus, and under this method I will call resource dot increment. So that's it, every time whenever this method will get called, it will increase the value of that count variable here. So now let me create two threads, that is thread t1 is equal to new thread, and here I will provide the runnable task to it, and let me give this a name, thread 1. Same way I will create another thread that is t2 is equal to new thread, and here same task I will provide, and I will give this a name thread 2. And now to start the execution we need to call t1.start, and then we need to call t2.start. So what t1.start will do, it will change the state of the thread from new to runnable, and same for t2 as well. And once it will acquire this increment method, it will go into the runnable state, while other thread will go into the block state. Thread state I have already explained in my previous tutorial as well under this same series, so you can check it out, that video as well. Suggestion you can see on top right corner. So now let me do one thing, let me print the last value, that is the final counter value. So before that let me write thread dot sleep, and suppose let me sleep this for 10 seconds, and after that I will add sysout statement, and I will print the final count value, that is resource dot get count, and it will ask me to declare the exception because I have used thread dot sleep, so let me declare it. So that's it. Now let me run this code first, and you can see after 10 seconds it will print the final value as 10. Already it has printed, but we have given the time of 10 seconds of waiting time, so that's why my main thread will go into the waiting state, and not waiting state, timed waiting state, because we have mentioned thread.sleep, and after that it has printed the value as well, that is 10. So here what we have done, we have used synchronized method. This will ensure thread safety, but all threads must wait for their turn, which can impact the performance. Now let me show you that how we can achieve the same output with the help of locks. What lock will do, it will provide a better control over acquiring and releasing the locks. And then one more problem is that with the synchronization is that there will be a thread which is waiting for the longest time, it will not get the resource immediately. But with the help of locks, that problem will also get resolved, that the longest waiting thread will get the lock first next time, and it will also help us to avoid indefinite amount of waiting. So first let me show you what changes is required. What I will do, under my shared resource class, here I will create one lock variable. So first let me write private, and let me create the object of lock. So it will come under java.util.concurrent.log package, and I will use lock is equal to new, and here I will create the object, and this object I will use while acquiring the lock. And this code now I am going to write under my try and finally block, because once the lock is acquired I have to release that lock as well. So for that I am going to use finally block. So first let me acquire this lock, so I will write lock.log. So here the lock will get acquired, and after that I will put this method, or not method, this code under try block, and finally I will use it here, so that even an exception has occurred, my lock will get unlocked, so that immediately the resource will get unlocked. So let me format this code first, and let me remove this synchronized keyword from here, and everything looks good. So now we can run this code. So let me run this code again, and we will see again it is generating the same output. Here you can see as well, it has printed 1 2 3 4 5 6 7 8 9 10, and finally after 10 seconds we got the final output as well, that is final count value is 10. So here what we did, we have explicitly acquired a lock and released the lock, as you can see in the code, which is written at line number 32 and 37. 32 is for acquiring the lock, whereas 37 is for releasing the lock. And one more benefit is there, is that the other threads don't wait unnecessary if they don't need the lock. So this is how we can use lock in place of synchronization as well to achieve the same output. I have shown you this simple example, but there are different methods which are present under locks, and there are different categories of lock as well that we will learn in the upcoming tutorial. So lock will help us to prevent from the race condition, but still they will block the threads, which can lead to performance issues. To overcome from that challenge, we can use atomic variables, which is present under java.util.concurrent.atomic package, and they will allow the thread safe operation without using the locks. So instead of using synchronized or locks, atomic variable use hardware level atomic operation, which will work on the compare and swap technique. This will result in better performance in high concurrency scenarios. So now let me show you the example of atomic variable. What I am going to do, I will create one atomic class first, and that atomic class will contain one atomic variable, and same output that we have generated using the synchronized and lock technique, same output we are going to generate with the help of those atomic variable as well. So first let me remove this class, and here what I am going to do, I will create another class, that is class atomic suppose variable. variable. And here what I will do, I will create one atomic variable, that is private atomic integer. So if you are working with the int, you can use integer. If you're working with long data type, you can use atomic long. For boolean, atomic boolean is there, and for object or classes you can use atomic reference. So I will give this a name, suppose count, and let me initialize it with the value that is new atomic integer, and initial value will be 0. And now what I'm going to do, I will create simple methods, that is one to increment and one to read. So I will write public void, and I give this a name, suppose increment. And here what it will do, it will just call one method, that is count dot increment and get. So it will increase the value by 1, and then what I'm going to do, I will print the sysout statement with the current thread name and the value that it has increased to. So I will write thread dot current thread dot get name, and then I will print the count value, that is count colon count dot get. And after that what I'm going to do, I will create one more method to print the final value or to get the final value. So public int get count, and it will return count dot get. So that's it. And now let me change the method above, so it will be atomic variable this time. So I will write atomic variable, and same thing will be applicable on right hand side as well. Let me call the constructor, and that's it. Let me remove unnecessary import, and let me save and run this code again, and we will see again it is printing the output, that is 10 finally. So you can see it here, it has printed thread 2 count 2, then thread 1 count 1, 4 3 6 7 8 5 10, and finally after 10 seconds it will print 10 as well. You can see it here. So same output we have generated with the help of atomic variables as well. So here what benefit we will get is that the atomic variables are non-blocking, and which can help us to avoid performance issues that can be caused by the locks, and these are best suited for the simple count based operations. So before discussing the best practices, let me tell you that where we can use atomic variables. So one, when we need the simple operations like incrementing and decrementing, in that case we can go for the atomic variables. And when we want to avoid locks for the performance reasons, in that case as well we can use atomic variables. But it is not suited for the complex operations that require multiple steps that you need to remember. So now let's discuss some of the best practices related to the locks and atomic variable. So first one is that always use try and finally block, so that even if your code has break under try block, your finally block will get executed and you are in the position to release that lock. And prefer to use try lock method over blocking locks to avoid deadlock situation. And use atomic variables for the simple operations like increment, compare and swap, and avoid atomic variables for complex logic. In place of that you can use lock instead. And don't mix atomic variables with the locks, as they can lead to inconsistent result. So to summarize, synchronized method ensure thread safety but have limitation as well, like blocking and no timeout handling, whereas lock provide better control allowing timeout handling and try lock mechanism. Atomic variable offer lock-free synchronization and better performance for the simple operation, and use locks for complex tasks and atomic variable for lightweight operation. So that's it for today's video on Dev Portal. Notes link I will give you in the description box as well as in the comment section, so you can check it out. And if you found this video helpful, please like, share and subscribe to Dev Portal so that you will get regular updates from our channel. And please share these videos with your fellow developers as well who are learning Java and database series. And I will see you in the next video on Dev Portal.